Hello, today we are going to be looking at two more types of shallow foundation and the type of situation in which you can use them, which are the mat foundation and the combined footings. So let's get into it. Hello everyone. Okay, today we are going to be looking at examples of other footings. So let's say you have two pillars like this, one like this and another one like this. Now, first of all, I want you to know this. When you are designing for footings, you are designing for the length, you are designing for the breadth or the width, you are designing for the height, and last but not the least, you are designing also for the reinforcement. That's the kind of rods that is going to go in there, and the shape and all that, the reinforcements inside. So let's say after designing the footings for this, you discover that this footing of this pillar is like this, while the footing for this pillar with respect to the load that the pillars are going to carry is bigger than this other one. So when you place it, it's going to encroach into the other pillar like this. So you see they are overlapping here. This is not how you are going to erect these footings on site. Okay, the way you erect this kind of footing on site is you construct one common footing which is going to take the both pillars like that. So you construct one common footing like this which takes both pillars, as you can see here. Okay, so you have this pillar in here and you have this type of footing is called a combined footing, which is the next type of footing that we are looking at. A combined footing like this. Okay, so what is happening here is we have not extended only the concrete to come in like this. No, not just the concrete. We have also extended the reinforcement. Let me demonstrate that by showing you this. Okay, now in the normal case of an isolated footing like this, what happens with the reinforcement is the reinforcement for the pillar comes down like this from the pillar, and then you have this. This is how the reinforcement comes down from the pillar. So you have one mesh or mat at the bottom which holds this reinforcement together, and of course at the top now you have the rods that are holding the reinforcement together like this. So you have just one mesh at the bottom. In this case, now let's bring out these pillars. So you are going to have this pillar like this, the pillar or the column like this, as you see here. And of course you have this footing. When it comes down, you have the footing like this, which extends all the way here. So this is the section. So we are cutting the section like this, and we are looking, let's say we are looking down, and this is what you have. So for the pillar is going to come down like this, and of course it comes in. So instead of having just one column mat like we have in the case of an isolated footing, in the case of a combined footing, you are going to have two, one at the top like this, and of course one at the bottom like that, and again of course now you then have the rods which are there now to hold the pillars together, the footing rather, together like that. So this is a combined footing. Okay, now let's go to the next type of footing, and let's take a little example again. Let's say your pillars on your plan looks like this. Let's say you have your pillars like this. Let's say these are your pillars. Okay, now the way you design the footings is, of course, you go to each pillar, you design the footing with respect to the load that each of the footing is carrying. You design them like this. So let's say after designing this, let's say you call this A1, call this A2. That's the surface area of the footing. Call this A3, and right up to the last one here, let's just call this AN. Okay, and of course looking at the surface area of the plot, let's call the surface, to calculate the surface area of this plot, it's going to be the length times the width. So it is the length times this width. So if, and of course the length times the width, let's say we call the surface area A. So the thing is, if A, which is the total surface area of this plot, okay, is less than or equals to 50% of the summation of AN, then you are going to, instead of providing isolated footings for each of these pillars, or combined footings if in case any of them is encroaching, you are going to provide what we call a mat foundation. Okay, a mat foundation simply means that you are going to provide one footing which is going to take all the pillars of the building. Okay, so instead of having individual pillars like footings like this, you are going to have one footing which will take all the pillars of the building like this. So of course in here now you are going to have all your pillars exactly the way they were before. So that is A1, A2, A3, A4, and we continue until you have AN here. Of course the difference here is that instead of having individual footings, that you have one footing, and we are having this. Why? Because it satisfies this condition. So if after summing all these areas of the footings, let's say A1, A2, so you sum this, you sum the surface areas of all these, and if you see that it is greater than or equals to 50% of the total surface area here, so let's say the total surface area that we have here, let's say the total surface area is 200 meters squared. Okay, the total surface area is 200 meters squared, right? And after summing all this, you have the area AN, that's the total surface area of all the individual footings. If let's say it gives you 105 meter squared, so if the total surface area of this gives you 105, now of course you see that it is greater than or equals to 50% of this, so we are going to go in for a mat foundation. Okay, so we do this, we do one common footing which is going to take all the pillars. But if let's say A was, say AN was, let's say 95 meters squared or something less, then we are going to go ahead and we do our isolated footings like we see here. And of course, for if we calculate and we see that we are going in for a mat foundation, and we have this, if we were to cut a section of this, if we were to cut a section, let's say through here, we cut and we look down, it is going to satisfy the same condition that we have up there for the reinforcement. So let's say we have this pillar, this, and this, and of course at the bottom you are going to have the one common footing which is like this, extends all the way like this. You are also going to have for the reinforcement, you have one at the top and one at the bottom, just like the case of the combined footing. And of course you have the rods that are here. But one point to note in the case of a mat foundation is you are going to have a greater depth than the isolated or the combined footing. Why? Because it is carrying the load of all the pillars. So let's say for the section, maybe for the section of your isolated footing, what you calculated for the isolated footings before, you were to go down a depth of, let's say 1.5 meters or 2 meters down. Now if you discover that at the end of the day you are going to go in for a mat foundation, then you might end up having to go at a depth of 2.5 meters or 3 meters even. And now it depends on what your structural engineer is going to tell you. So that is it for the different types of isolated footings. We have looked at a combined footing and a mat foundation today. So I hope this helps. If you are finding these tutorials helpful, please don't forget to like and share them. And also you can subscribe and follow us to always receive notifications on all tutorials that we will be bringing up. Thank you and see you in the next tutorial.